Okay, let's consider the shop floor layout on the screen. And each machine on that shop floor operates with a known probability that you can see. What's the probability that throughput can get through the shop floor? Okay, that is, what's the probability that we can start on one end of the shop floor and get through to the other end? So let's think about this in a little bit different way. Let's consolidate that picture down to, let's call it the top and the bottom. Okay, so we have two different ways to get through the machine floor. Okay, let's just refer to that string as the top and that string down there as the bottom. Okay, and let's identify some events. Let's call event T as top works. That is, all of the machines in there work. Remember, this would be a series system along the top. Okay, so what's the probability that we can get through the top? That's this event. And let's identify event B as bottom works. Okay, that is, we can get throughput from here through the bottom and out the other side. Okay, therefore the complement of T would be the top doesn't work. The complement of B complement, would be that the bottom doesn't work. Okay, so let's identify what's the probability that the top works. Okay, for the top to work, that means that all of those machines, those three machines in series, have to operate. Okay, so what's that probability? For the top, that would be 0.9 times 0.8 times 0.7. What's the probability that we can start here, go through the top set of machines, and then come out the other side? That's that probability, which is 0.504. Okay, therefore, the probability of the complement of the top works, okay, the top does not work, would be 1 minus 0.504, which is 0.496. Okay, now let's find what's the probability that the bottom works. Okay, probability that the bottom works is 0.95 times 0.95 times 0.95. Each one of those has the probability of working of 0.95. That, if we work that out, is 0.857. 0.857. Okay? So the probability of B complement would be 1 minus 0.857, which is 0.143. Okay, so now we have a new diagram here, a simplified version of what we see on the screen. And now we want to know what's the probability that throughput can get through the shop floor. Okay? So what are the ways that we can get from here to here? Well, if either of these work, we're good. Okay? So that's one way. So the probability that the top works and the bottom works, that event, top and bottom, will get us through. If the bottom doesn't work and the top does, or the top works and the bottom does not, okay, we can still get through. And, excuse me, the probability that the top does not work, but the bottom does. If the top doesn't work, we still have this option to get through. So top doesn't, bottom does. Okay? So this probability, okay, if we find this, we can find what's the probability that this thing, that we can get throughput through this shop floor. Okay? So let's calculate these individually. The probability of top and bottom is, these things work independently, let's assume. That would be 0.504 times B, probability of B, 0.857. Okay? And that is equal to, well, let's not calculate these intermediately. Okay? The probability of top and B complement, that would be 0.504, and B complement 0.143. And let's look at the probability of T complement and B. Okay? T complement is 0.496 and B 0.857. Okay? This gives us this probability over here, the probability that we can get through the shop floor. If we do all these individual multiplications and sum them up, we should get the value 0.929. Okay? So given these individual component probabilities of operation, what's the probability that we can get from one side of the shop floor to another? That's 0.929. Another way to think about that is what's the complement of this thing not working at all? If we calculate what's the probability that both of these options don't work, take the complement of that, that gives the probability that it does work. Okay? So if we find the probability of T complement and B complement, take the one minus that probability, that would give us the probability of this, essentially. The probability that we can get through from one side to the other. Okay, that's equal to 1 minus the probability of T complement times the probability of B complement, which is 1 minus the probability of T complement, which was 0.496, times the probability of B complement, 0.143. If we do that, we should get 1 minus 0.071, which is equal to 0.929. Okay, so same way to get these two answers. And as it turns out, so what this is, these are two subsystems that are in parallel, and the subsystems are in series. Okay, so we have a combination of series and parallel in this shop floor system.